Concept of magnetic field. You are very much welcome to this class. Do you know that a magnet in some way has an effect on the space around it? That is why it can arrest any nail close to it. You learned sometimes ago about force field, that a force can be exerted through space without actual contact. In this lesson, we are going to discuss the concept of magnetic field. Anna's outcome. At the end of the lesson, you should be able to define magnetic field, describe the magnetic field around a bar magnet, describe the magnetic field around a current carrying straight conductor, describe the magnetic field around a current carrying solenoid. Let us examine the idea of the magnetic field. Know that when you bring a piece of roving nail to the space around a magnet, the nail moves or is arrested by the magnet. This space has been changed by the force exerted by the magnet, and the nail is under a magnetic force field. Therefore, magnetic field is a region around the magnet in which the influence of the magnet is experienced, just like the king of a king in our time. Next, we are going to describe the magnetic field around a bar magnet as shown in the next slide. We have to place a bar magnet on the box and place a white paper on top, as we can see, and drop iron fillings uniformly and lightly on it. And you can see that the iron fillings are much at the poles of the magnet, highly concentrated than other areas of the magnet. You can also trace the radial or circular arrangement of the ion fillings to show the magnetic pattern around a bar magnet. Next thing we do is to describe the magnetic field in the current carrying straight wire as shown in the next slide. To demonstrate the magnetic field in a long straight current carrying conductor, we made it to pass through a cardboard like this and connecting the ends to a battery through a switch and switching on the current. We now drop iron fillings at about 20 centimeter height uniformly on the cardboard. And now hit the cardboard gently. You can see how the iron fillings realign itself in a concentric circle around the wire, which demonstrates the magnetic field pattern in a current carrying straight conductor. Last to be examined is the magnetic field of a current carrying solenoid. I'm going to show you a demonstration that shows the magnetic field around the current carrying solenoid. A solenoid is made by wounding a long straight wire over a test tube having a thread of several turns. This is a solenoid now. We now switch on the circuit and now drop iron fillings at a height to the solenoid on the cardboard. Drop it lightly and uniformly round, and now hitting the table gently. You can now see the iron fillings around the solenoid tracing the magnetic field pattern of a solenoid. Can you give yourself the correct answers to these questions? What is magnetic field? Describe the magnetic field pattern of a bar magnet. Differentiate between the magnetic field pattern of a current carrying straight wire and a solenoid. For further reading, the lesson had enabled us to describe the magnetic field of a bar magnet and those produced through current. For further readings, New School Physics for Senior Secondary by M.W. Anyakuwa, Senior Secondary Physics by P.N. Okeke and others.